Okay, it's recording now.
So Courtney, you have some work for me? Instructions? Turn in the constructions?
Yeah, I wanted them to you Thursday.
Okay.
Like to you personally, by the door.
Is this like spell work or?
Did I hand them back to you? Are you sure you know what I'm asking for?
No, he's probably just recording the rest.
We're taking like one pen. Oh, well. The bell hasn't rung yet.
Excuse me? Thank you. No, this is naming angles. The other one was constructions. We did a construction of a line segment, copy of line segment, copy of the angle, perpendicular lines, perpendicular bisecting an angle, and the last one was parallel lines. So make sure you do number 6, you do the parallel lines. And then you have to Can you come in before school? Yeah. Okay, let's do before school.
Does that not work? So we just write all that down?
Mr. E, I'm gonna bring probably Derek and Christie. Step in so they can see they don't know.
All right. I got to inform these guys too.
Okay, sounds good.
I can just leave that door open this morning so they can just
Okay.
come in and out.
Sounds good.
About it.
Fresh air.
All right. So first of all, there's some bell work on the board. If you could take out a piece of paper, pencil, write down the problems, and complete this or start it now. And whatever you don't finish will be homework for tomorrow. Okay? So whatever, leave it open. Heather, can you leave it open? Yeah. Thank you. Yeah.
Do you want to start the questions on there?
Yeah, I don't think you'd be able to answer it if you didn't know what the question was. Yeah, I think that'd be wise. Thank you for asking us. Anthony, you're here? Okay. Eleanor's not here. Alex is not here. Jacob, thank you. I'm sorry. I don't know why you called you Nick earlier. I'll get it right here eventually. So. Sure. Did you have a question?
Yeah.
Could you raise your hand at your seat? And I can come answer your question. Rather than come up here. Yes, sir.
When do you think you'll have Thursday night's homework, Friday night's homework?
Yeah.
Do you have it right now, or?
Yeah, ask me Wednesday, I'll make sure you get it.
Oh,
Because I'm not sure how fast we're going to progress to that point. Friday, you know, is going to be a test, right?
oh, so I have to take that.
You'll have to make it up next week.
Okay.
All right, so as you're writing that stuff down, I'm going to pass back your test results to you. I have tests from last week. I'll pass those back to you. You can record them on your tracker. Okay, record them on your tracker, and then I'll pick these back up. These are not yours to keep. These are yours to keep just for a few minutes. We'll go over it together, and then we'll go from there. Okay? Okay. Derek? Chris? Kristen?
would be
Carolyn? Are you writing any of these down? Oh, all right. This goes. Zach. David. Chaz. All right, I'm going to have to take these off the board eventually. So if you've been wasting time, you're not going to have them all down. So let's just figure through problem number 2.
Nice.
Okay, through problem number 2. Those are really going to pertain to what we're going to cover this week anyway. So if you can get through 2 and write that down in your book, we'll be all right.
How do you do number 2?
But evaluate
That's
-2.6.
what I want you to figure out. This is kind of like a little, so the bell work that I'm doing is kind of like a little review. There's nothing on here that we didn't do last year.
I don't remember.
Okay, so there's nothing on here we didn't do last year. So if I only have 2 questions and you have access to a computer tonight, you should be able to figure out the answer to this question, right? Or how to do it.
Yeah.
Okay, all right, do that for
Figure
me.
the answer.
So if I go on my computer and type in evaluate,
Line.
-2.6.
That says absolute value of -2.6.
Oh.
Okay.
Okay, all right.
I think I know how to do that.
But I want you to understand how to do it once you do that, right? So what's taking place in class now and it's going to be every day?
Bell work?
Chaz.
What?
Is we're going to be videotaped in class. Awesome. He's going to do us a favor of doing that, and the reason that's going to take place is when you're absent, right?
Yeah.
When you miss a day, you're going to be able to go on YouTube and look at the lesson.
Hey.
That's cool.
Okay?
We're gonna be making millions.
Now, I gave you guys a YouTube or a. I'll wait for you.
We're gonna hit 6 million followers.
I'll wait for you. I gave you guys a website last year to go on to study for the AZ Merit. And only about 4% of you did that. So, just because it's there doesn't mean you're going to use it. You need to know it's going to be there. Okay? You'll be able to go back and watch the lesson for that day. So when I give you the paperwork that you come back and get, you can go and watch that video of that day's lesson. Okay, make sense? Okay. So you'll get instruction just like everybody else got instruction, same instruction. Okay? Now we're going to do that every day. We're just going to see how it goes. Hopefully it'll work.
Well, what would you have to tape up?
They'll give you the YouTube channel. It's a special channel. It's already set up. Okay? But you're going to be able to log in and watch it. Okay?
Well, Thursday and Friday, you have on the YouTube channel?
Yes. Cool. But Friday is going to be a test. So it won't matter.
Right? Maybe I can like look at the test. Maybe if you hold up the test, I
No.
can zoom in.
All right. So let's look at the tests a minute. You have them there on your desk. Number 1, we did number 1 in class, almost identical to that. And number 1 is a picture of an equilateral triangle, the construction of an equilateral triangle. We did that one in class. Hopefully nobody missed that one, but I actually saw some people that marked circle construction. It is not circle construction. It is the construction of an equilateral triangle.
Well, because first
Okay.
I had that, and then I was like, no, wait, that's way too easy.
This whole test was way too easy.
Yeah.
Number 2 says what is demonstrated by the construction of figure B. Well, if you remember your constructions, figure B was a construction of parallel lines. Some people put perpendicular lines. First of all, those lines aren't even close to being perpendicular. They're at an angle. They can't be perpendicular. Okay? It would be parallel lines. Parallel lines. Not congruent line segments, parallel lines. Okay? And number 3 says, what is demonstrated by the construction down below? And I did this twice. We did this twice, right?
I don't remember.
We did a construction of perpendicular lines, segment, bisector. And then we did it, so that was 3 on our list. And then we did 4. And 4 was perpendicular lines. And I said, there's a difference. And I circled what the difference was. This difference is one has arrows and the other one's a line segment. So if you have a line segment, it becomes a perpendicular bisector. And if you have arrows, it's just perpendicular lines. So some people actually put bisecting a line segment, and it's not a line segment because there's arrows there. You have to look at the picture. And since there's arrows there, it's perpendicular lines. Okay? Construction of perpendicular lines. So the correct answer would be D. You have to look. Remember I said that geometry is really about observation? 90% of this class is about observation. Can you observe a figure and determine what's going on? And that means you have to look. And some of you get in a really big hurry of taking a test and wanting to turn it in so bad it's burning a hole on your hand because it's so hot. You got to get rid of it. It's hot. You got to turn it in. Don't do that. You guys can get straight 100s on each and every one of these tests if you just took your time. And reread the questions more than once. It's not about trying to get done first. Listen, you're going to have the entire period to take these tests because I have to have all these tests graded by the end of the day. And if I'm going to have all these tests graded by the end of the day, I'm not going to be teaching anything else on Fridays. You're just going to be taking the test. When you're done, you're going to read. So why not take your time and get 100%? And that way you won't be in reteach. Okay. All right, let's go over the other side. The other side says, what are the steps to bisecting an angle? And you kept asking me, am I going to have to know those words step by step? Every single word. Some of you did. You did an excellent job. You had the words, word for word, memorized and put on that list. Some of you came close, and I gave you credit for coming close. And some of you didn't even look at the definitions. You didn't even look at the steps. And I can tell by the answers you gave me. Or you tried to remember it 10 minutes before class started. Or the 10 minutes I gave you in class. And if you do that, it doesn't work. Okay. You got to look at it ahead of time. Okay. And I made notes on those, saying, like for instance, if you said put the compass, I said from where? On what point? Little notes that if you weren't as accurate as you should have been, I put notes to say what you should have included. But if you came close, I still gave you credit. All right, any questions on this test? Record it on your tracker, and then I'll pick it up. Okay, Mr. Drummond. I see that you put this up there in my box. Your hand into it, right? Well, this one's supposed to be the construction of a copy of a line segment, right?
Yeah.
Okay. Where's the original?
What do you mean?
Well, you copy something, there's going to be two. There's going to be original, there's going to be a copy.
I don't really understand, I just like.
Okay?
make those
So rather than turn this in, come in and see me, or take out your packet that I gave you ahead of time and do a construction of a line segment. But if you don't have an original one, How do you make a copy? You can't, it's not about just drawing a line segment. Anybody can do that, right? No, we're not drawing a line segment. We're creating a copy of a line segment using a compass and a straight edge. Okay? So you gotta have original, then you make a copy. Okay? Same thing with angle. I see that that's,
And I didn't
you
see it.
drew 90-degree angles on each one. This is done exactly the same as that. The only difference is there's arrows on it, just like the picture on that test. Okay? So why don't you come in one day and see me, and we'll see if we can, or if you're going to be in reteach, I'm going to show those videos again. You can practice those in that class. Okay? All right, go ahead and pass those tests up for me, please. Thank you. Thank you. All right, this week, geometry. Hopefully by the end of the week, you're going to be able to algebraically, and yes, we're going to be using algebra. Right? So hopefully by the end of the week, you'll be able to algebraically determine whether or not lines are parallel or perpendicular to help you solve geometric problems. Yes, ma'am? I haven't even finished the day yet.
I know, but like
Are
you
you
don't ever
leaving?
write anything on the board.
I haven't wrote anything on the board
I
yet.
know, you didn't want to hear, so I didn't have anything on my
Well, you
agenda.
got a
So
raise
your
last
parents
week.
yelled at me.
You got a race last week.
Are you gonna write stuff up there this week?
I will. I wrote it up there last week too. They just got a raise midweek. Okay. Could you hide those for me, please?
Yeah.
Thank you.
I don't know what to do with them. I'll just take them.
Just stick them in your shirt.
Or I'll just take them.
Or just take them out.
It's complicated.
All right. So we're going to start off with a PowerPoint presentation on writing equations. Now, last year in algebra, we actually did this. In algebra, we introduced this topic. We worked on it for about 2 weeks, probably, if I remember right. And then we're going to work on it here in geometry. And then when you get to Algebra 2, you're going to work on it again. This is one of those topics that doesn't go away. It's going to keep on going. Guys, sit down, please. Yeah, you can do that later. Yeah, just so you know, once I'm starting the presentation, that's when I hand you that. That's not time to get up and go start punching holes. I understand that you want holes in. I'm going to try next time to make sure that happens, so that you don't have to worry about that. Okay. All right. So you have 2 slides on yours per page. It is front and back, so it doesn't take up as much room in your binder. But what we're going to be doing is we're going to be writing equations. So hopefully by the time we're done, you're going to be able to write an equation for a line that is parallel or perpendicular to a given line. If you remember last year, we had slope-intercept form of a line, right? Y equals mx plus b. That's the slope-intercept equation for a line. We call it slope-intercept equation of a line because you can easily pick out the slope of the line. The slope would be represented by m, and you can easily pick out the y-intercept, which is represented by b. So that's why they call it slope-intercept form. So writing equations, you're going to have lines that are in slope-intercept form. there's a relationship that's given as parallel or perpendicular, and hopefully you're going to be able to find that slope and that y-intercept for the new line. All right, so we're going to start off by letting you know what a line parallel to another line contains, okay? So on the bottom of this particular paper, you're going to write the definition of parallel lines, okay? So on the bottom of this paper, you're going to write the definition of parallel lines. So right underneath your example 1, parallel lines have the same slope but different y-intercepts. Okay? Parallel lines have the same slopes but different y-intercepts. Now that's as good a definition as we need when we talk about parallel lines, because it's pretty simple, right? Once you have an equation in slope-intercept form, a line parallel to that line would have the same slope but a different y-intercept. So let me give you an example. Let's go back to this one so we can make it a little bit bigger. All right. So I know to have a line parallel to this line, it's got to have the same slope. Here's my slope. And it's got to have a different y-intercept. So if I was going to write a line parallel to this line, I could say that new line is y equals negative 2x plus 2. Because it has the same slope, but a different y-intercept. I could say, David, that the new line is going to be y equals negative 2x minus 3, because that's a different y-intercept. That's a positive 3, negative 3, those are different. I could say y equals negative 2x plus 5. That would be a line parallel to this line, because it has the same slope but different y-intercept. Okay? Anybody have a question on that? Because I'm going to ask you to tell me an equation of a line that's parallel to this.
Can there be decimals? Or
Can there be decimals?
like 3.5?
There could, but why?
Just
But there could.
That one time. That
But there
half
could.
Right in between the two.
Absolutely could. All parallel lines mean is the lines are going the same direction, and since slope is the slant of the line, right? And they're not on top of each other. If they have different y-intercepts, that's what causes them not to be on top of each other.
So
Okay.
like y equals negative 2 plus 4.
Yes. All right, so we're going to start here. Yeah.
That's fine.
Give me the equation of a line that's parallel to this line. Y equals negative 2x, right? Same slope, so go ahead and start there.
Y equals negative 2
X
x negative
minus 3. That's a line parallel to this line. Has the same slope, different y-intercept. Miss Barney?
Y equals negative 2x minus 4.
Okay. Y equals negative 2x minus 5. Don't give me the same one twice. Go ahead, Anthony.
Y equals negative 2x plus 5.
Okay. Devin?
Y equals negative 2x plus 4.
Y equals negative 2x plus 4.
Y equals negative 2x minus 4.
Minus 4.
Y is equal to negative 2x plus 25.
Okay.
Y equals negative 2x plus 2.
Y equals negative 2x minus
Minus 10.
Y equal to negative 2x plus 40.
Plus 42. A little louder, I'm sorry. Nobody heard you.
Y is equal to 2x minus 4.
Negative 2x, right? Negative 2x.
Y equals negative 2x plus 6.
Y equals negative 2x plus 7.
Y equals negative 2x plus 77.
Negative 2x minus 7.
Okay.
Y equals negative 2x plus 9.
Y equals negative 2x plus 895 and 2.
Y equals negative 2x plus 80.
Y equals negative 2x plus 9.
Y equals negative 2x plus 5, or 7.
Okay.
That's already been said.
All of those are parallel lines. Okay? All those are parallel lines to this line. Some of them are repeated, and if you repeated one, those two are not parallel to each other. The repeats are not parallel to each other because they have the same slope and the same y-intercept, right? The only time you can have parallel lines is if you have two lines that have the same slope but different y-intercepts. Those are parallel lines. If I were to put them on a graph and graph them, you would actually see that they're running the same direction, but they're not touching each other. That's the definition of parallel lines, right? Two lines that run the same direction, but don't touch, don't intersect. Okay. Come on. All right. Now let's talk about perpendicular lines.
Is this just changing the slope?
On which one?
In perpendicular lines, is it just the complete opposite?
Well, let's take a look. So here's a slide on perpendicular lines, right?
Yeah.
Here's a slide on perpendicular lines, and the definition of perpendicular lines. So perpendicular lines have negative reciprocal slopes. Perpendicular lines have negative reciprocal slopes. And let me give you an example of that. Okay? So if I have a slope that has a slope of 2/5, okay? The reciprocal to that means that same number flipped upside down. Okay? That's what reciprocal means. The same number flipped upside down. Okay? So the next one would be 5/2, but that's not the only thing there is. Because it's a negative reciprocal. Negative reciprocal just means opposite. Right? Negative is just opposite. So if it's positive, it's going to be negative. If it's negative, it's going to be positive. So when we say negative reciprocal, we don't necessarily mean put a negative in front of it. We mean the opposite. So if this is a positive, this would have to be a negative. If this was a negative, this would have to be a positive. Okay? So since this one is positive on the left, the one on the right would be negative. Okay, that would be an example. Let's do one that's negative. So if I have a slope of, and let's do this one, if I have a slope of -2, this is going to be a tough one, what would the negative reciprocal of that number be?
Positive.
2.
Oh, close.
Positive 1.
There you go. 1/2. And
I'm so confused.
I'll tell you why. Because
Oh.
-2 is really -2/1.
Oh, I
So when I flip that number upside down, it becomes 1/2, right?
Well,
I told you it was going to be tricky, right?
I get it.
Yeah. I told you it was going to be tricky.
So if it was a -3, then it would be 1/2.
1/3.
You just put 1 above it?
Yes.
Okay.
Super easy.
Yeah. Because if it's -3, it's really -3/1.
Oh.
And then if I flip that number upside down, it becomes
Yeah.
1/3.